Good day, guys. Welcome to episode 4 of the series Building a dApp on Cartesi using Rust. So, in the last episode, we looked at what notice is. We built a simple calculator dApp, and in that app, we're able to send in input as users and also receive a notice with the result of the calculation we did. So, the calculator we implemented in the last episode was able to carry out 4 different types of arithmetic operation. We worked on the addition, subtraction, division, and multiplication. And we were able to test that out, visualize the input and also the output through using the Cartesi Explorer on a local machine. So in today's episode, we'll be going more further for what we've been doing in the last 3 episodes. So we'll be building a more advanced app this time around. We'll be building, look at it as a student registry application. So this application will be able to um, allow a user register student. Then we're able to implement something new, which is more of like look at it as like access control, or you can look at it as like user personalization. So the user is going to be able to register students, fine. Then students themselves are also going to be able to sign attendance. So you're going to have or implement a counter for every single student. So each student now, once they sign an attendance, their counter increases. So be able to track the address for a particular student. Then when that student calls a function, we're able to know that okay, student A called this function, so we are increasing his attendance. A lot of blockchain applications actually implement this. For example, we have token contracts. So where each user has a record of his balance on the platform. We have music streaming platforms on chain where each user has a record of their so the songs they've listened to and a whole lot of other things like the subscriptions, the musicians they follow. On DeFi platforms, sorry, on the social media platforms, we have users to a record of the contents they like, the content they've posted, and stuff like that. So personalization is a key feature in blockchain application. In basically in almost every application we see. So we'll be taking a step further today to look at this and also touch on another key concept, which is reports. Our application will not just allow teachers or mentors to register students and students to take attendance. Our application is also going to enable uh, anybody to query the list of students. And once they query the list of students, they get the total list of all the students on the platform and also the scores for each individual student. So we are going to be touching the inspect routes in today's application. So if you miss any of the previous application, I like to advise that you go back and check those episodes out. As always, we'll be here waiting for you when you come back. So stay tuned and let's get straight to coding. Welcome back, guys. If you've been following us for the previous 2 episodes, you know that once we want to start building our project, one of the first things we do is to bootstrap a new dApp using the Cartesi CLI. So we'll be going straight to the point now to bootstrap a new project, then go straight up to build. So here we go, guys. We now have a new repository bootstrapped for our today's project. So as normal, one of the first thing we do is to import a very important library or dependency which we'll be using, which is the hex library. So we go straight up to cargo.toml file, then add this here, hex is equal to 0.4. So guys, now that we've been able to bootstrap our new dApp, and we've also added the hex dependency, which will be making use of a whole lot. I would like to go further now to the implementation for the code itself. So since you know today's dApp is going to be a student registry dApp, we need certain storage or basically certain storage that we need to implement, and not just storage, certain data types and also certain functions that are unique to this data type. In Rust, we call this implementation. So I'll need to create a struct for the student's data, then also create 2 implementations or a single implementation that contains 2 functions for that is unique to the struct data. So this struct is student struct, but we need two functions in this struct. One of them is to create a new struct, then the second is to sign attendance. So since that struct is unique to each student, there should be a unique function for sign attendance. So we'll be implementing that now. So let's go straight to that, guys. So guys, with this, we've been able to implement the storage struct for students, an implementation that contains a set of functions that are unique to the student struct. And what we also added here that I didn't talk about initially is we implemented a vector. So look at a vector like an array that we know in regular programming. But the difference is with Rust, if you're implementing an array, you need to either specifically state the number of values or contents of the array, that is the length. You need to implicitly state the length of the array while creating it. So for this student registry now, we do not know the exact amount of students we'll be having once we make it dynamic. And a vec is similar to an array. The only one of the main differences is that with a vec, you do not need to specify the length of the vector. But it's similar to an array you can add and remove from the vector. But with the vector, you do not need to state the unique or the total length of that vector while creating it. So what we did here is we just implemented a vector, an empty vector, and called it student data, and that student data is going to be holding a vector of students. So we create new students, we push them into the students array that we have here in the main function. The reason why I'm adding it here is because once we start this dApp on Cartesi, it's going to be more of like static. So it's going to be more, look at it as a persistent storage. So it's going to retain the content of this array even while we are in the loop of like receiving arguments from users, returning back response and stuff like that. So after doing that, the next thing we did is to send in a reference to this array, mutable reference to be specific, of this vector to the handle advance and the handle inspect function. The reason why we're doing this is that the handle advance especially function needs to be able to edit the content of the student data. So once we receive a request to create a new student, the handle advance needs to have access to this vector so you can create a new student structure and push new students to it. While the handle inspect does not necessarily need to have a mutable reference to that vector, but it needs access to the vector. So if there's a request to fetch a particular student's attendance or a particular student data, then you could always pick data or read data from the reference to the vector which we pass to it. So that's the reason why we just added this. So since we are done with this, we'll be going forward with handling payload, that is converting this payload to hex like we always do, and also uh, checking the different like doing more of like checks to know the particular function the user is calling, then implement the functionality for these different functions. So let's continue. So guys, what I've done here is first thing I did is, as always, printing out the payload, exact payload we receive. This is going to be in hex format. Then next, I'm extracting the exact person or the address that is sending a request to us. Then the next is these two combine are basically just converting this hex payload we received to a regular string. But since it's going to be an advanced function, I'm just expecting a string from our users. We are expecting a JSON object. So even after getting a string, we need to still pass that back to a JSON object so that we can decode the arguments and the function method the person wants to call. So before that, we are printing out the string we got. Then after which we are converting that string to JSON like we've seen here and sending it to or storing it as JSON data. So after which the next thing we are doing is to get the method. So we are getting the method from the JSON data we got. So that method, we are now matching on that method to check what exact function this user wants to call. So for now, we are implementing just three functions. One is to create a new user. The second is to delete a new user, an existing user. Then the final is for a registered user to sign attendance. So these are the three methods we support for now. And what we'll be doing next is we'll be going straight up to implementing each and every one of these three functions. So let's start with the create function. So guys, what we've done is we've been able to um, implement functions for create, delete, and also sign attendance. Then we've also called these functions for if the method the user is trying to interact with is any of these functions basically. So for create students function, the first thing we're doing is we are collecting the value that's the entire data chunk the user sent to us. Then we are collecting the vector of student details. Remember, it's a reference to that. Then we are extracting the name, getting the name from that JSON value. Once we get the name, converting it to string. Um, we are trying to extract the string record here. Then we are calling an expect method basically. So if there's an error, this expect method catch that error, then console logs that error to us. Then we are doing the same thing for age. The only difference is that for age by default, this is coming in as okay. We could change this to as U8, so we do not need to have this. So what we are doing is we are collecting the user's age, automatically typecasting it to a type U8, then the extraction method, expect method to catch any error and also convert the result to a regular U8 type. Then wallet address similar to the name, we are getting the JSON value, converting it to string, converting it in option type, which is either sum or a none. Then we are extracting it. If it's a sum, we are returning the data. If it's a none, then we are throwing an error. Then if there's any error message, we are converting this result to um, the regular type. Then we are throwing an error here. So this is basically what we are doing for this set of data type. So once we've gotten the name, age, and the wallet address, the next thing we are doing is we are calling the student struct we have up here. Remember, there's it. Then what we are doing next is we are creating a new object. We're calling the function new, and we are creating a new student object, passing in the name and also the age, and finally the wallet address. With this, we create a new student, then we are pushing it into our student data type. So we have one student waiting in that vector of student. Then the next thing we have is the student, the delete student. Delete student is similar to the previous type, just that this time around we do not need, it's similar to the create student, but this time around we do not need the name, the age, the wallet address like we did before. What we need here is just the wallet address that we want to delete. What we do is we extract this data like we've done previously. You should know that by now. Then we are creating a new variable here to hold the index. So next thing we are doing is we are looping through our entire vector. We are looping through the entire vector. Then we are using this conditional that if, okay, for each student inside that student's vector, if the student's wallet address in lowercase is equal to the wallet address we just passed, also in lowercase, then we are getting the index and storing it to this first found index. The reason why we're converting this to lowercase is string comparison is normally very funny at times. So if a lowercase letter is different from an uppercase letter, so what we're doing here is we're trying to unify both of them. So the user might pass in an address as in uppercase or in complete lowercase, while the address are stored in database in a combination of uppercase and lowercase. Well, with this, we've been able to convert both sides to lowercase, then run the comparison. Then since we've gotten the index of that particular student in the vector of students, next thing we are doing is we are calling this student data, then which is a vector, then we are removing the index. So look at it like pop, but this time around pop, we are not popping from the bottom of the array. We are calling a particular index. We are like, okay, for this particular array, remove the variable or the child at this index. So it's like a method that already exists for vectors. So we just call it, give it the index, and it removes the value or the child in that particular index. So with this, we've deleted the student. So we are just printing out, okay, that we've deleted the student, or if we don't find that student, we'll also emit, like print out that, okay, we couldn't find that student. For now, we are not doing anything much. We need to implement two more functions, one for reports and another for notice. So for every successful event, we emit a notice. Then for an unsuccessful event, we emit a report basically. So that's that. And the next thing is the final is the sign attendance. So what we're doing here is same thing. We are looping through student data, the vector. Then once we find a student that has the wallet address that is trying to sign an attendance, we call the student, we pick the students and call the method that we already have in vectors, take attendance. So similar to what we have here in remove, you see, okay, we just call student data type that is a vec and call the remove. So what we are doing here is we are calling students a call take attendance. So this remove is like a method that is already existing for vectors, but we weren't the one that wrote out that method. It comes default with Rust. But for students, we implemented this method take attendance here. So it's like every vector, every student type, every vector that contains a student type, or not even a vector, every struct that is of student type has this take attendance method automatically. You can just do the dot notation and call that method and it's going to work. So we've done that, we've called the take attendance and we're automatically increasing the student attendance by 1. The next thing we're doing is we are printing success. If there was an error, if we couldn't find the student, we also print out that we couldn't find the student. So the next thing I want us to do now is I want us to write out functions, two functions, one for emit events, emit a notice, and the second to emit a report. So we will now start referencing. What we'll do now is to start referencing the function to emit a notice or emit a voucher where necessary. So guys, with this we've been able to whew, this has been a lot. Well, with this we've been able to create our image notice and also our image report functions. These are basic functions, same as what we had in the previous episode. The only difference between the report and the notice is the fact that we changed um, this line here to report and this line here for notice to notice. Then what we are doing here is we are currently encoding uh, the data we get from whatever data we get from the function calling the emit notice, that is a payload. We receive it and we convert it to string, then hex encode it, convert it to hex. But remember, this hex library, it does not deal with 0 and x in front of the hex value. So what we are doing here is we are adding that 0 and x to this. After adding it, then we are setting the response as an object with a key payload. Then what we are doing now is to emit a notice with this response. Same for report payload and emitting um, a report with that JSON object. So with this, we've been able to successfully create three functions that create a student, delete a student, and also allow the student to sign attendance. So let's just confirm something here. Yeah, we need to wait for this set of functions. This is an asynchronous function. So remember that the difference between the sign attendance and these other functions is for the sign attendance, we are passing in the student data, that's the entire data that which is not even necessary. We are passing the entire data of that is so it's necessary actually. So we are passing the entire student's data, that is a vector. Then you're passing in the address of the user that is trying to interact with it, that is mh.sender. Then the client and the server are just variables that we need to emit a notice or a report. So once we get those two, we do the whole looping, find the exact student, then carry out the signing of attendance. Then for these other ones, you are passing the JSON data, which is the arguments, like the wallet address you want to delete or create, the name, and also the age and other variables, depending on what you want to add when you are building your own version of this. So with this, we have a functional advanced, handle advanced part. So what I want to do next is to touch on the handle inspect. So I told you this time around we're working on handle inspect route. So we want users to be able to make a call to our dApp through the inspect route. So once they make a call through the inspect route, we want to be able to return certain important variables, important data to them without having them go through the GraphQL server. I think we'll just be doing two major functions. One is okay, you pass in an address. If the address exists, it gives you the attendance of that address, or just the complete data chunk of that address, or you just ask for the entire list of all the entire data in the database. So let's get straight to work. Okay, guys. So with this, we've been able to also implement two methods here to fetch all students. So what we're doing under the handle inspectorate is once a user make a call to the inspectorate, we are also getting payload, which is the imp user person as passing in as X. So we print it out here first. Okay, this is what the person passed in. Then we convert that X to a string. Then in this case, you do not need to convert it, pass it to an object because it's just a code the user is making on the browser. So we're expecting it to be a string. So, but what we need to do now is we need to slash that string because just like a regular URL, my user might want to pass in different paths, like www.cartesi.org slash the page you want to visit. But in this case, we are expecting that, okay, for example, user wants to get the details of a particular student. So you can pass in student slash the address of the student, then you can get the details of that particular student. So what we are doing here is that we are splitting it at every slash. So you can get the main object you want to get or the method you want to call, then the argument you're passing to that method. So that's why we are slashing it. The next thing we are doing is we are matching on that slash, that's string slash the index 0. That is the first one, which is expected to be the method. So if that method is all students, that means you want to fetch all the students. What we are doing is we are just formatting, passing the entire student data vector into a string. So you're converting it to a string and outputting it out to you, then sending it out to you as a report. Then the next thing we are doing is if you are trying to call students, that means you are expecting that, okay, you want to get details of a particular student. So we are checking the wallet address, which is the index 1, the second argument you are passing. So we get the index 1, expecting in order to get the error, the particular value or throw an error. Then we are looping through the entire student data vector to find a student that has the same wallet address as what you just passed in. Once we find that student, the next thing we are doing is we are formatting that student object into a string. Yes, once we get it as a string, we are making a report with that particular student string, student data object. So you're going to be getting the name, the age, and also the wallet address, and possibly also not possibly, but also the attendance count of the student. Then if there's a mistake, that if the student does not exist, then what we are doing is we are emitting a report that, okay, we couldn't find a student with that wallet address. Okay, so with this we've been able to successfully write the dApp. Today's video, today's dApp is a whole lot more complex than what we built previously. So let's try this out and see what we are getting. So I just spin up a new terminal. And if you've been here with us during the previous episodes, we like to use two terminals for this particular section. In one of them now we build and run, in the second terminal we interact with the dApp. So let's go straight to this. So we'll give this a while to build. So if you're working with this, if you're coding along with me, just be patient, give it a while to build. So depending on your system, your internet connection, and some other stuff that is dependent on, like that's your system capacity, your RAM, it might take a while to build. So just be patient, give it time. So once it's done building, we'll run. After running, we interact with data. Also, I forgot to mention, very importantly, make sure you have Docker running. For me, I have, you can see Docker desktop is running here. So I have Docker running, that's why I'm able to run this command. Because if you don't have Docker running, you're obviously going to get an error. But if you have Docker running and you still run into an error, you can reach us to us on Discord. That is a Cartesi Discord. Just drop your complaint and I'll be able to help you sort that out. Okay, so we are done building, and the next thing we'll do is to run the program. Okay. Whew. moment of truth is here, guys. let's see what let's see if we're going to have any bug in this code or if it's going to run. This is one of the largest dApp operating out in a single go. So I'm kind of expecting that we might experience errors here or there, but let's see how it goes. Okay. Okay, so let's make this call. Okay, so on the part of the logs here um, we have received payload is this, received request as string, converted to string is this, then created new student SpongeBob. That's nice. Then hex value is this for the output. Then we posted. That's nice. So it seems this worked. So let's go to the Explorer. Let's go to Explorer and see what we have here. So this is what we passed in. Notice Aztec student with name SpongeBob and address created successfully. That's nice. That's very nice. So let's try one more time. Let's create a new student. So Cartesi generic same. So you're trying to create another student, Mr. Krabs, and he also worked. Going back to the terminal, going to input. Let's refresh this. So we have another input, Mr. Krabs created. Cool, cool, cool. So the next we'll be doing now is to let's try signing an attendance. Let's sign an attendance. So let's see foundry RPC name this. So let's sign attendance with SpongeBob. So the method we want to call this times. Sign attendance. And for sign attendance, you don't need to pass any argument. Just make the call. Sign attendance. I have here signed attendance for SpongeBob. Let's go back to the inputs and confirm one more time. So coming here, we see an input created 10 seconds ago as text. Yeah, attendance signed for SpongeBob. So that's good. We're doing great. We're doing great so far. So what we need to do next is let's visit the inspect route, then make a call or make a query to get one of these data. So let's go to inspect. Let's see what we're going to call. We'll call the all students function first. So inspect, paste this in, enter. This is beautiful. Copy, then let's get the hex. So we have here a list of all our students. This is a vector in form of an array. Students name, SpongeBob, age 18, wallet address, attendance count 1. Remember, I've signed an attendance for SpongeBob. Then the next is student name, Mr. Crab, age 23, wallet address, attendance count 0 because we haven't signed attendance for him. So what we can do now is on the front end, we could pick this up, decode this, destructure this, how you want properly, then utilize this on the front end. So let's make a call specific to get just um, SpongeBob data. Okay, using account, because that's the address of SpongeBob 70. Yeah, just confirm it, 709. Then student. Okay, and we also got an input. Go back to our hex reader. This, and we have here student's name, SpongeBob, wallet address. So it means, what this means is that our dApp is functioning perfectly. So we've been able to test out majority of the functions implemented. That is the create student, sign attendance, visualize both a single student and the general student's data. Then one last thing we're here to do is, okay, we're here to delete a student. So let's delete Mr. Krabs. Okay, and here we go. Okay, I have a record there. Deleted student is one letter address this. So this is beautiful. So let's go to Cartesi scan and see the output we got from this. So we'll go to switch to Cartesi scan, view all inputs, last input, and notice. So here we have the student with address. This address deleted successfully. Our input was, as just said, method delete wallet addresses. So with this, we know we have a fully functional dApp. Every single component of this dApp is working, from creating a student to deleting a student, and finally to signing attendance. So with this, we've been able to create a fully functional dApp that serves as a student registry. So it's more like an attendance management where we could register students and different students could sign attendance and just track student progress. On your end, you could make this a bit more robust to implement things like, okay, whitelisting of accredited staffs. So making a way that only registered staffs can add students and stuff like that. Then you could also modify it in a way that only that students now could also store. You could store students' exam record, test records, and a whole lot of other more complex features about the student. So that is that for what we'll be building today. Some of the things I want you to remember is how to implement personalization on your dApps on Cartesi. You just need to pick or dwell mostly with the msg.sender, msg.sender, comparing this with what you have in the database and stuff like that. Then I'd like you to notice where we used reports and where we use notice. Remember, sending out output from output for inspect request, we use report. Sending out output from inspect, we use report. Sending out error messages, we use report. But if a user carry out an execution that changes the state of the tab and you want to send out an information about that, then use a notice. That is when you use a notice. But if there's an error in your tab and or user is trying to access something that does not exist, always emit a report. If a user is trying to inspect, call the inspector out on your tab, always also use a report to send out the log of what you want to showcase to the user. So I believe we've been able to do justice to this today, and we've covered most of the important concepts of building this dApp and also testing out this dApp. This video is really getting very, very long. So I'll stop here for today, and I want you to try this on your own. If you experience any issue, any bug, reach out to us on Discord. We'll be able to help you sort out your issues. So stay tuned. Remember to practice this on your own. Stay tuned for the next episode. I'll be going more further to implement something more interesting. So stay tuned for episode 5. And as always, Remember to stay lost, you guys.